Today we'll talk about SQL injection attacks. In a SQL injection attack, user-provided data is used in a database query, but it is interpreted as code rather than as data. The XKCD comic that gives a nice example of how a SQL injection attack can be. Before we get into the details of SQL injection attacks, we'll first go over a common architecture used on the web. There is a web server front end with a SQL database backend. So we have a client that is browsing the web, a web server, and a database server. The client submits some form to the web. So there is a post request to the web server. And here, for example, the client might be logging in and as part of the form, they have to fill in their name and their password. And of course, hopefully the site is using HTTPS, so the password is not being sent in the clear. But when the server receives the request and decrypts it, this is basically what the server will have. The web server constructs the query dynamically using data from the user, from cookies that were sent by the browser, and from variables and data stored on the server about this particular user. So this query here says, and this is a SQL query, it says select star, so that means select all the rows from the password table in the database where username equals, and then you can see there's the open quotes, a single quote, and then there's a variable name. And then the query continues where username equals the variable name and password equals, and again, there's a single quote, the string ends, we have a variable password that will be concatenated, and then the string continues with a closing single quote. So those variables, there are two variables here, name and password, and they will get filled in with data. In this case, that comes from the user supplied data. So the web server constructs the query, the SQL query, and here's what that final query looks like. It says select star, that says select all the rows. Select star from the password table where username equals Alice and password equals Cheshire. So you can see this is the full SQL query, the full string that gets sent to the database server. The database server executes the query, looking up the records, the rows in the database which match the query. And the result gets sent back to the web server. So here there was a match. In this case, the name is Alice and the ID is 45. The server uses this information to create the response page that will get sent back to the requesting browser, the client. And finally, the response page gets sent back to the client. So here you can see the server has constructed this page, and in the body of the HTML page, it's going to say, welcome Alice. So it uses the users. So now let's see how a SQL injection attack works. Here, the client is the attacker, and the attacker types in the string shown in blue here. This is the same form, the same example that we're looking at. But what the attacker types in is the word root, single quote, space, dash, dash. So that's what the attacker types in. It's shown here in blue. The attacker provides no password, leaves that field empty. And again, the web server constructs the query dynamically using data from the user, from cookies sent by the browser, and from variables and data stored on the server about this particular user, if any exists. So in this case, the name variable will get replaced with the attacker provided string, which was root, single quote, space, dash, dash. So that's what will get filled in here. And here is the final query that gets sent to the database server. In SQL, everything after the two dashes is treated as a comment. So that weird extra closing quote is ignored as part of the comment. And there's no constraint in this query that the password field equals some value. The and password equal, all of that is just part of the comment. The only constraint for this query is that the username equals root. So again, the database server executes the query looking up the records in the database which match the query. And so in this case, the only requirement is that the record has the username equal to root. And the database server returns the results, the name and ID of the return database entry, which is for the root account. Now, as far as the web server is concerned, the client has authenticated as root. All right, let's look at another example. Here, the attacker types in a different username. So here the attacker types in single quote, space, or, space, 1 equals 1, space, dash, dash. That's what the attacker types in to the name field on the form that's asking them to log into the web page. The same idea, the server constructs the query. And I'm going to pause the video here. Well, I'll pause talking, the video will continue. And before we go on, I want you to think about what the final query is going to look like. So I'll pause for a few moments. Okay, let's see what that query will look like. The query is now for every entry in the password table where the username equals, so it says select star, select all from password table, where the username equals, and you can see the empty string, right? The single quote, so that's an empty string. So where the username equals the empty string, or 1 equals 1, and the rest of this is all part of the comments. So for each entry in the database, the query asks, is the username an empty string, or does 1 equal 1? And the answer will be true for every entry in the database, and so every entry gets returned. That is a SQL injection attack. The defenses that we have to defend against SQL injection attack are really three kinds of defenses. We have prepared statements, input validation, and escaping. So a prepared statement is a way to provide a template where it ensures that the query that gets passed on is formed, the query that gets passed on to the database server is first formed by the code on the web server. The query itself is formed. And so what is provided by the user can only be used as text, as data, cannot become part of the control structure of the query itself. And so this is called using prepared statements. The web server prepares the query that it is sending on to the database server as an object, a query object, and whatever the user provides is only interpreted as text within that query object. Another defense is to use input validation and to look at what the user is providing and sanitize that user input in order to prevent any kind of control mechanisms, control statements making their way into the final database query. And another defense is to escape. So to not allow any control sequences or control characters making their way into the final query. SQL injection is a form of code injection, right? The attacker is able to provide code that the database server is willing to execute. So the attacker is providing the SQL query or part of the SQL query that gets executed by the database. It is a form of code injection. It arises because data and control share a channel or can share a channel, right? The attacker, the user, has to provide some data, such as their username or their password, but there is no separation between the data channels and the control channels, right? The part of the query that is the control, the part of the query that has, for example, select, where, select star, where, all of these things, right? That's part of the control. It can just be formulated as one string where the control and the data share this one channel. They're all part of the same one string. And as a defense, input sanitization is needed. So if we look at our principles of security that we have talked about in the past, Two principles of security that are violated here are separate data and control channels and this idea of never trusting user input. And these are two security principles that need to be adhered to in order to prevent SQL injection attacks.